is Linda. Today, inshallah, we're going to solve practice problems on Doppler effect. Now, what is Doppler effect? Doppler effect explains frequency changes caused by moving sources or moving observers. So here we have two observers, observer 1 and observer 2, and here we have an ambulance. The ambulance is producing sound. So this is my sound source. Sound, if the sound source now that has frequency f is approaching the observer 1, so it's approaching observer 1 at speed v source. What will happen to the wavefronts? The wavefronts here will punch together and you will hear frequency f prime, which is higher than the original frequency because the sound source is approaching, so he will hear higher frequency. So the frequency here, f prime, greater than the original frequency produced by the ambulance. Lambda here, the lambda, you see the wavefront distance between two wavefront, lambda is small, is short, but the frequency will be higher, so you will have higher pitch or higher sound. On the other hand, observer 2, the ambulance is moving away from him, so sound, the sound source recedes from the observer at speed vs or speed of source. The wavefront, you see, the wavefront will stretch out the distance between two consecutive wavefront. This is wavelength lambda, so I have lambda here, lambda is large. So what will happen to the frequency observer 2 will hear? He will hear lower frequency, so the frequency here, f prime, will be less than the original frequency of the sound, lower frequency. Okay, so what is the formula for Doppler effect? We're going to Doppler effect. We're going to use this formula times V positive or negative V naught divided by V positive or negative Vs. Now, what is f prime? F prime is the observed or shifted frequency. F is the original frequency of the sound. V is the speed of sound, Vs the speed of source, here my source is the ambulance, and V naught or VO is the speed of the observer. Now we'd have many cases for Doppler effect. We will start with the two simplest cases. Case 1 and case 2. Case 1, if I have stationary source, the source is not moving. The observer is moving. So the velocity of source is 0. V source or Vs will equal 0. If I have a stationary source, so in the denominator, this one will equal 0. So the formula will equal V prime will equal F times V sound, positive or negative V observer divided by V sound. The other case, if I have stationary observer, the observer is not moving, but the source that produced the sound is moving. So if I have stationary observer, in this case, the velocity or the speed of the observer is 0, it's not moving. So the formula will become f prime will equal f V sound divided by V sound, positive or negative V source. Let's start with case 1. When should I use positive and when should I use negative? Now, if the observer, we said the observer is moving observer. So if the observer is approaching the source of sound, he will hear lower pitch, lower sound. So f prime should be greater than f. That means I have to add. So I'm not going to use the minus signs, I will add, and this is my logic. Anything in the denominator, if I want to make it bigger, the number, just add two numbers together to make it bigger. On the other hand, if the observer is moving away from the source, the frequency f prime will be less than the original frequency, so I'm going to use the minus sign. So case 1 is easy because I have the numbers in the numerator. Just add when you approach, subtract when you recede. The second case, I have positive or negative in the denominator. In the numerator, if I add, the whole number will get smaller. So I will get higher frequency. Frequency will be higher if the number in the denominator get smaller, get lower. How the number in the denominator get lower? Just subtract. So I'm going to use minus sign, minus next to the velocity of source. If the source is approaching, in this case I will have higher frequency. So here f prime will be greater than f. And here when recede, I will use positive. That means f prime in this case will be less than f. We will hear lower frequency. So we're going to use this formula to solve practice questions on Doppler effect. We will start with the first question, and first question will be in case number 1. You are in an auto. The auto traveling with a speed 25 meters per second toward a pole mountain warning siren. So this is the source, and the source is not moving. Okay, so this pole mounted warning siren. So V of the source will equal 0. The source is not moving. The observer, which is U, is moving. So this velocity is V of the observer will equal 25 meters per second. If the siren frequency, this is the original frequency of the source is 365 Hertz. What is the shifted frequency? The new frequency you will hear, the observer will hear, f prime, how much? The speed of sound, V, 343 meters per second. We're done with the given. Just write the formula and substitute. So second step, right? So f prime will equal f v, velocity of sound, positive or negative velocity of the observer, divided by velocity of sound, positive or negative velocity of the source. So f prime will equal f 365 343 plus velocity of the observer 25 divided by v of the sound 343. Observe source is stationary, is not moving, so 0. And this will give me 392 Hertz or per second, second inverse. Okay. Now, why did I use positive? Because the observer is moving towards. The observer is moving towards, so I will hear high pitch, so I'm going to add a positive. There is small things I forgot to tell you here. In case 1, we can use, you can always remember this one, OTA, observer towards add. So if you have moving observer and a source is 0, OTA, observer towards add. And here, if you have stationary observer and the source is moving, so STS, source towards subtract. And it's logic, source towards subtract, because you will hear in the denominator, you will hear, you will increase the frequency will be increased, so you will hear high pitch. Okay, let's continue. We'll take another example. We have a submarine is moving toward another submarine at 9.2 meter per second. It emits a 3.5 megahertz ultrasound. What frequency would the second submarine at rest? So submarine is moving toward another submarine, and this submarine emits ultrasound. So a source is moving. The source is moving. The velocity of the source is 9.2 meter per second. The source that produces sound. It emits frequency 3.5 mega times 10 to the power 6 hertz. I need the new frequency, the shifted frequency. If the observer, which is the second submarine at rest, so the velocity of the observer is 0. This one I don't know. Okay. And the speed of sound in water is 1000. So here I have V, 1482 meter per second. Okay, same, write the formula and substitute. So F prime will equal F, V positive or negative, V for the observer, divided by V positive or negative, V for the source. V for the observer is 0, so this term we can cancel it out. Now, what should I use in the denominator? Positive or negative? The submarine, the source, moving towards. Now remember, in the denominator, source, toward, subtract, because you will have higher pitch. F prime will be higher if the denominator, all the denominator is less. We'll have high sound. So how can I make it less? Just move, choose the subtraction sign. So the answer will be F prime will equal F 3.5 times 10 to the power 6, 1482 divided by 1482 minus 9.2. And this will give us 3.52 times 10 to the power 6 hertz, or 3.52 mega, 10 to the power 6 is mega hertz. Another question. You have a sound source, please, middle C. The frequency is 262 hertz. How fast would the source have to go to raise the pitch to C sharp 271 hertz? So the source now is moving. Source is moving. I need to find the velocity of this source. I don't have it. When the source is moving, its frequency will increase. The original frequency was 262 hertz. The new shifted frequency is 271 hertz. Okay, so source is moving. I don't have observer. The velocity of the observer is 0 meter per second. Use this number to, so this is V, speed of sound. Same thing, write the formula and substitute. And remember, source toward, subtract in the denominator. So we'll write the formula. F prime will equal F, V positive or negative, V observer divided by V positive or negative, V source. F prime 271, F is 262, V speed of sound 343. I don't have the observer's stationary, divided by 343 minus. Why minus? Because in the question he tell you to raise the pitch, which means I have higher frequency. The frequency here is higher, the denominator should be less. The denominator should be less, so that's why we use subtraction. And always remember, STS, source towards subtract. Minus what? Minus V. I don't have V. There is no V. Okay. This is math skills. So here I will have 271 multiply, cross multiplication. I'm going to multiply it by 343 minus V will equal 262 times 343. This will give us 89,866. Now distribute and simplify. So 271 times 343, it will give us 92,953 minus 271 times V will equal 89,866. Take this to the other side and simplify. Divide both sides by 271. So the final answer V will be 11.4 meter per second after you simplify the answer. Okay, one more question, but this time we'll take a question when I have both. Observer is moving and source is moving. Okay, same steps. You are in an auto traveling at 224 point is moving towards you with the same speed. So you are the observer now. The observer is moving. So your velocity, the velocity of the observer is 24.6 meter per second. And I have the source that produces this noisy sound. It's horn, which means it's producing a sound. So V for the source, it's moving towards you. So you will hear high pitch, okay? Moving towards you with the same speed. 224.6 meter per second. It has a frequency, so the original frequency for the sound, 475 hertz. I need the new frequency you're going to hear, and use this one to represent the speed of sound, 343. Write the formula. Okay, so first step, we're going to write the formula. The formula I have, F prime will equal F times V positive or negative, V observer divided by V positive or negative, V of source is moving towards you, which means I'm going to choose the positive sign here and the negative sign here, because STS moving towards subtract, this number will become higher. F prime will be greater than F. How I'm going to make F prime, the new frequency, higher than F? By increasing the numerator and decreasing the denominator. So the denominator should be less. So the answer will be like this. Okay. Prime will equal, what is the value of f? F is 475, you open bracket, speed of sound 343, plus 24.6 divided by 343 minus 24.6. And the new frequency will be higher, will equal 548 Hertz. It's higher than the original frequency, which is 475. Okay, we'll take one more question, and I hope it will be now clear for you. One more, we'll solve one more question. You have a train. The train is moving toward a sound detector at 31 meter per second. The train flows. So here we have a source of sound. The speed of this source of sound, 31 meter per second. So this is Vs, 31 meter per second. Blows, so the original frequency F, 305 Hertz. Whistle, the speed of sound 343. What frequency is detected? I need F prime. In the following cases, if I have a stationary train, so the velocity of the observer is 0. Write the formula and substitute. Okay, so let's try the formula. I will have F prime will equal F V positive or negative V observer divided by V positive or negative V source. Observer, its velocity, I don't have, this one is 0. Moving towards, remember, I have numerator. In the denominator, STS, source, towards, subtract. Or remember, moving toward F prime should be greater than F. How I'm going to make F prime higher? The denominator should be lower, so I have to use the minus sign. So F prime, just substitute now. F is a 305 times 343 divided by 343 minus 31. And you should get 335 Hertz. Second case, I have the train is moving toward the first train. So source and observer, both of them, they're moving towards. The velocity of the observer here in this case is not 0. Velocity of the observer is a 21 meter per second and towards. So towards again, F prime will be F. In the denominator, it will become positive. Denominator is moving towards, will become what? Negative. So this is V minus Vs. So F is 305, V 343 plus 21 divided by 343 minus 31, the velocity of source. And this will give us 356 Hertz. Same question, but instead of moving towards, moving away. Same question, but here the train is moving away. The train is moving away. Moving away in this case, you can use F prime will equal F. In the denominator will become negative. So V minus V, the observer. The observer is moving away, and the denominator, why is moving away? Because F prime should be less than F, the new frequency should be lower. How are you going to make it lower? By reducing the denominator and increasing the denominator. Okay? So always remember STS moving towards subtract, away معناته, which means we have to add. So this will be V plus V of the source, and you solve you continue solving the question. I will keep this one as a homework for you. You should get the final answer here is 2.63 times 10 to the power 2 hertz. And same question, okay? And this one, it's 2.8 times 10 to the power 2 hertz.